Hello, 7th grade homeschool. I'm James, and today we're going to be doing a lesson focusing on estimation. So the learning objective is to estimate an answer to a calculation. Success criteria: to estimate the answer to a simple calculation by rounding to one significant figure, to estimate the answer to calculations involving fractions by rounding to one significant figure, and to estimate square roots. What is estimation? Write down your answers to the following questions. What do you understand by estimation? What do you think is involved when estimating? Why do we estimate? Okay, and now quick exercise, round the following numbers to one significant figure. So 4.8 to one significant figure will become 5. 10.2 to one significant figure will become 10. 196 to one significant figure will become 200. Remember, zeros do not count as significant figures. They don't have any value. They do have value because it makes it 200, but they don't count as a significant figure. 451 to one significant figure, 500. 2.45 to one significant figure will become 2, and 0.52 to one significant figure will become 0.5. Now this one's slightly more complicated, 0.098 to one significant figure. So if you had to get one significant figure here, this would be rounded up, so it would become 0.1. Sometimes we don't need to know the value of something exactly. Write down some examples of things we could estimate. So some examples from the other lesson, maybe how many people are watching a football game. I don't know, how many views something gets on the internet. Yeah, something like that. Sometimes an estimate may be good enough for us to make statements or perform calculations. To estimate answers to questions, we round up or down to nice numbers that make it easier to calculate mentally. We can round to one significant figure to make these nice numbers. So here we have two separate questions. We have 34.99 times 26 is equal to 984.54, and 27 times 3.04 is equal to 62.80. Are these calculations correct? How would you know? So let's look. 34.99 times 26. That is actually equal to, just gonna get a pen over here. That is equal to 909.74. It's not equal to that. And then 27 times 3.04 is equal to 82.08. So these answers are actually incorrect, these two. So these are the correct answers here. We can use estimation to decide whether these calculations might be correct. So how we could estimate this, we could use one significant figure over here, but it might not be as accurate as we want. So let's use two significant figures. So we're going to go, so I'm going to write it over here. So we want two significant figures for this 34.99. So that will give us 35. And then we can leave 26 the same. And that will be equal to 910. So you can see that is a good estimation because 34.99 times 26 is equal to 909.74, which is very close to 910. So what you could write here is you could write 34.99 times 26. Okay, this is going to be quite hard to write, but this is the equal sign for approximately. So it's a squiggly equals. Okay. And then you can say 34.99 times 26 is equal to approximately 910. So this does not mean it equals exactly, but it's a good estimation. So let's move on to the next one. So here we have 27 times 3.04. So here we can estimate this by rounding to the 3.04 to one significant figure. So we will have 27 times, then we're going to round 3.04 to one significant figure, which will give us 3 equals, we can calculate that, 81. And then draw an arrow here. And then that will mean that 27 27 times 3.04. These are pounds, these answers. So this will have the pound symbol. It's quite hard to draw. And yeah, all of them will be pounds because we are multiplying by pounds here, so don't forget the unit. And then that is, we're going to do the approximately equal to sign. So 27 times 3.04 is approximately equal to 81. And we can look, is that a good enough estimation? Yes, it is, because 82.08 is quite close to 81, so that is a good estimation there. So here we have two separate estimations. We have the first estimation, and the actual answer is 909.74, and the estimation we found was 910 pounds. And then for the second one, 27 times 3.04 pounds, the actual answer is 82.08 pounds, and then the estimation is 81 pounds. So that's the second answer, and that is the first answer. So how can we estimate 49 times 57? We can estimate the answer to this calculation by rounding each integer to one significant figure. So 49 times 57. So if we had to round 49 to one significant figure, that would go to 50, right? And then if we had to do the same for 57 to one significant figure, that would become, that would round up because it's above the midway point. This also rounded up, by the way. So 57 would round up to 60. There we have 49 and 57 rounded to one significant figure. So there we have 50 times 60, which gives us 3,000. And here's the approximately equal sign that I was speaking about earlier. That is how you draw it. And remember, this is not the same as this. So you need to make sure when you write it, you actually put effort in to make it a bit squiggly, just so your teacher or examiner will know that it isn't this sign. Now we are asked to approximate the value of 51.6 plus 52.8. So again, I'll write over here, 51.6 can be approximated to one significant figure as 50, and so can 52.8. 52.8 can also be rounded down to one significant figure to 50. So there we have 50 plus 50. That's easy enough. That is 100. So that means 51.6 plus 52.8 is approximately equal to 100. So now we're asked 167 times 14 is equal to 12,221. Give a reason why this is correct or incorrect, and give a better estimate of the answer. So let's first find out if this is correct or incorrect. So 167 times 14, so if we do that, we can actually do it the long way if we want to just practice our skills of multiplication. So let's just do that because it's always useful to remember how to do this. So we go 4 times 7 is 28. And then we go 4 times 6 is 24, but we add the 0 because now we're timesing by the tens column. So it's 244 times 60, that is what we're doing. So, and then we add 2 more zeros because we're talking about the hundreds column. So 4 times 1 gives us 4, or it would be 4 times 100. And then we move on to this 1 here, or it's actually a 10 because it's in the tens column. So we put a 0 there. 1 times 7 gives us 70. 1 times 6 gives us 6. And then finally, write the 3 zeros because we're timesing tens by hundreds. 1 times 1 is 1. Let's add these up and see if they are correct. So we have 8. And 2 plus 4 is 6. Plus 7 is 13. So we write the 3. We carry the 1. 1 plus 2 is 3. Plus 4 is 7. And then plus 6 is 13 again. And then we carry the 1. And then we write the 2 there. And then we can check that with a calculator. 167 times 14 is 2,338. So this answer is actually equal to 2,338. All right. So this is incorrect. So give a reason why this is correct or incorrect. The only reason I would be able to think of is just because that is not the right answer. I don't know what else to say. When you do the multiplication, this is actually the right answer, and we proved it over here by writing it out in long form. So now I'll give a better estimate of this answer. So there are probably different ways to estimate this. If you use one significant figure, let's do that. For both of them, it's not going to be very, very accurate. So if we use one significant figure for both, we'll have 100, because 167, excuse me, it won't be 100. We'll have 200, because 167 to one significant figure will be rounded up to 200. And then we times that by 10. So it's reasonably accurate. We get 2,000. So not too bad of an estimation. But you could make a slightly better estimation by using one significant figure just for one of them. For example, this one. Actually, this is the best way to do it. Keep it with just one significant figure. That's what the rule said earlier. So as a final answer, we would have 167 times 14 equal to, approximately equal to 2,000. So there's our answer there. So let's just run through this question quickly again. So it gave us this equation here, and then it said, is this correct or incorrect? And it was incorrect. And then we proved it using the long multiplication method, and we got 2,338 as the answer. And then we wrote it there. And then to estimate it, we rounded both of these to one significant figure, 167 and 14. So 167 goes to 200. And then 14, it's rounded down to 10. And when you multiply that out, you get 2,000. And then that is a reasonably good estimation of 2,338. Approximate the value of 792 plus 496.2 all over 0.52. So we're going to round all of these to one significant figure. So 800 gets rounded, and 792 gets rounded up to 800. 2 is rounded up to 800 because it's above the halfway point. 496.2, when rounded to one significant figure, gets rounded up to 500. And then finally, 0.52, which I'll write up here. When rounded to one significant figure, this is the most significant figure over here, this 5. So we will round it down to 0.5. And then we do that calculation with 800 plus 500 over 0.5, and we get 1,300 over 0.5, which gives a final answer of 2,600. And then we can say that all of this statement here is approximately equal to 2,600. and we can see what the actual answer was. So 792 plus 496.2 all over 0.52 is equal to, okay, so we can add 792 plus 496.2 is 128.2 over 0.52. 0.52, and that gives an answer of, so this is the exact answer, 2,477.307 ... Okay, so this is in fact a good estimation of this. Estimating square roots. What two integers does the square root of 59 lie between? Think, which perfect squares are close to 59? So the square root of 49, which is 7, and the square root of 64, which is 8. So now we can see clearly the integers that it lies between. So there we go. We have 49, roots of 49 equal to 47, and the roots of 64 is equal to 8. So the square root of 59 lies between 7 and 8. Okay, now we are asked to approximate the square root of 125 to 2 decimal places. So for the first one, question 1, 125 is greater than the square root, the square root of 125 is greater than the square root of 121 and less than the square root of 144. So that means the square root of 125 is greater than 11, because we know that this is equal to 11, and we know that the square root of 144 is equal to 12. So it's in between 11 and 12. Therefore, the whole number part of the answer is 11. Find the difference between the given number 125 and the lower perfect square. So 125 and the lower perfect square is 121. So that gives us 4. And then find the difference between the greater perfect square and the lower perfect square. The greater perfect square is 144 and the lower perfect square is 121. That gives a difference of 23. And then we are asked to estimate or round 4 over 23 to 2 decimal places. So if we write this out, we get, so 4 over 23 is equal to, you'll probably have to use your calculator to work that out, and this would be 0.1739, and there would be more numbers here. And now we are asked to round it off to 2 decimal places. So we'll look after the second decimal place, and we can decide if this can be rounded up or down. Is it going to be 0.17, or will it be 0.18? And how we decide that is if it's above the halfway point of 0.175 or below that halfway point. And in this case, it is below this halfway point. So we can round it down, and then so we round 0.1739 to 0.17. So we can say 4 over 23 is approximately equal to 0.17. Here you can actually just say it is equal to, because we are just rounding it down and we're not doing a huge estimation. So we're losing a bit of information here, but it's almost equal to. But yeah, the approximately equal to is slightly more correct. Let's move on to the next question. Oh, and then for this one, root 125 to 2 decimal places. it just told us that the whole number part is 11. But if we use our calculators, if you guys are allowed to use calculators, then we'll find that the square root, move this thing out the way, the square root of 125 is equal to 11.18033 ... And then we're going to round to 2 decimal places, just as we did here. And we're going to decide if the numbers after the second decimal point are above the halfway point or below the halfway point, in between 11.18 and 11.19. So the halfway point is 11.185. And this is below the halfway point. So if we approximate the square root of 125 to 2 decimal places, we will get 11.18. So the answer. Could write the squiggly ones, squiggly equal signs. Yeah, let's move on to the next one. So 11 plus 0.17. Okay, so this gives us the so all of these are leading up to this answer. It's very close, but we are approximating, remember. So this is if we just rounded it down directly. So if we did use a calculator to check our answer, that's what we would get, to 2 decimal points. So this isn't what you should do. This is just to check. And then, so then we find the difference between the given number, 125, and the lower perfect square. And then we find the difference between the greater perfect square and the lower perfect square, 23. And then we use that as a fraction. And then we find that to 2 decimal points. And then we will add that to the whole number of 11. So we know that the whole number is 11 because the square root of 125 lies between 11 and 12. And it's less than 12 and greater than 11. So it must be 11 point something. So what this means is, so it's greater than 11 but less than 12. So it'll be 11 point something. I'm just going to write x here. And then we need to find out on top of that. So the first step is to find out that it's 11. And then we need to find out what this x will be, or what's going to be the decimal points. And then so we find the lower perfect square, the difference between the given number, the lower perfect square, which is 4, and then the difference between the greater perfect square and the lower perfect square, which is 23. And then we use that to get this fraction here, and then we find that it's 0.7 to 2 decimal points. And then we just add here, so we know it's 11 point something plus the 0.17. And then we get a final answer of 11.17. I'm just going to clear all this, and then you guys can pause and you can read through all of that again if you want, and try and make yourself understand that. Let's move on. Okay, here we go. The approximate value of the square root of 125 to 2 decimal places is 11.17. Refer back to your answers from the beginning of the lesson. What do you understand by estimation? What do you think is involved in estimating? And why do we estimate? Have your thoughts changed? And summarize your progress in 3 points. And that is the end of today's lesson.